So 4 is greater than 1, but we're going to multiply both sides by a positive number. So times positive 2, which gives us 8 is greater than 2. Is that still true? Yep, we're doing good so far. So far, we've added to both sides, we've subtracted to both sides, and we've multiplied both sides by a positive, and each time we ended up with a true statement. So moving on, 4 is greater than 1, and we're going to multiply both sides by a negative number this time, so negative 2, which gives me negative 8 is greater than negative 2. Is negative 8 greater? Is it closer to 0 than negative 2? No. So that ends up being a false statement at the end. Dividing both sides by a positive. So I'm going to do 4 is greater than 1, but I'm going to divide both sides by 2, which gives me 2 is greater than 1/2. True or false? True. And then the last one, start with 4 is greater than 1. But we're going to divide both sides by a negative number. So I'll do negative 2, which gives me negative 2 is greater than negative 1/2. Is negative 2 closer to 0 than negative 1/2? Is it greater than negative 1/2? No, it's false. So which 2 gave us a problem? Negative subtractions. Some people think of that as it's really adding a negative, but it's really the multiplying by a negative and the dividing by a negative that caused our problems, right? So what would be a super duper easy fix to make this a true statement and to make this a true statement? What could we do? Flip the sign. So I'm going to take this out, and I'm going to say negative 2 is less than negative 1/2. And negative 8 is less than negative 2. So do you guys remember this back from Algebra 2 and Algebra 1? If you multiply or both divide both sides of an inequality by a negative sign, what do you have to do? Flip the sign. Now, it kind of makes sense. So think of my arms as a number line, and my head as a big goose egg, 0. So where is the smallest positive integer? Where's that? Right here, right? It would be like on the right, your right side of my head. So here's the smallest positive number. But where is the largest negative number? Think of it. The largest the largest negative integer would be my other shoulder, right? So the number line is kind of weird because we have the smallest number right next to the largest number. And in order for those number lines to match each other, you have to flip it backwards. So then the largest number is with the largest number. Does that make sense? So basically what we're doing by changing the sign is we're flipping the number line. If you take a positive number and you suddenly turn it to be negative, you have to flip everything backwards so the number lines match up. Okay? So here, this is on your pretest number 3. So get that out real quick. 4C on the pretest. What mathematical operations reverse the sign of the inequality? So I'm going to put them in one step. I'll show you. There's another one technically. But what were the 2 things that we said we had to flip the sign? Multiply or divide both sides. That's important. You have to do it to both sides by a negative. Multiply or divide both sides by a negative. So like we just did, if I have 4 is greater than 1, and I multiply both sides by negative 2, the left side is negative 8, the right side is negative 2, but in order for this inequality to make sense, I have to put a less than sign instead of a greater than sign. And then the other one is if you interchange the sides. You interchange the sides. Now what I mean by that, let's say I have x is greater than 2. Say that backwards. Yeah, 2 is what? Less than x. If x is greater than 2, that means 2 has to be less than x. So if I want to switch this backwards, you also have to take the sign with it. X is greater than 2 is the same thing as saying 2 is less than x. So those are the only two scenarios in which you would ever flip an inequality sign. Okay. Now the next one is 4D on your pretest, and there's 3 scenarios. The first one is if you just simplify one side. So these are which you would keep the sign unchanged. You don't change the sign. So let's say I have like x plus 2 minus 3 is greater than 4. If I combine my like terms and if I do 2 minus 3 and get negative 1, do I need to change my sign? No. Not if you're just doing it to one side. If you're ever just simplifying one of the sides, you don't have to change the sign ever. The next one, on that page we were just on, what were a couple of them that we did not have to change the sign? So one of them, yeah, let's say multiply or divide both sides by a positive number. Multiply or divide both sides by a positive number. And what other two operations left it unchanged? Yeah. Add or subtract from those sides. All right. Now we're going to do some true or falses. You don't have to, oh, sorry, real quick. This is, keep reading this. This is number 4E. This is 4E on your pretest, the transitive property of inequalities. You actually learned the transitive property of equality in geometry. Remember, A equals B and B equals C, so therefore A equals C. It's the same thing. It's just less than signs. So if some number is less than some number, and that same number is greater than, and that number is greater than another number, what does that tell me about the first number and the last number? Yeah, 4 is greater than 1. So if A is greater than B and B is greater than C, then A is greater than C. It's your transitive property of inequalities. All right, on the board here, this is F1, or Fi, whatever that is. And number 4 is F2I. So both of these are on your pretest. So let's do these first. So the important thing here is comparing the first sign to the last sign. That's what they're asking. Is that a true statement or is it a false statement? That's the whole point of this whole sentence. So if we start out with A is less than B, and if all these letters confuse you, pick some numbers. What's a statement that's true where A is less than B? 1 is less than 2. And what does this mean? Some C value is less than 0. What is less than 0? It's a negative number. So we're adding, now this is important, we're adding a negative number, which is really just what? Do what? What's adding a negative? It's really just like subtracting, right? So they're saying take some number and subtract it from both sides of your equation. So if I subtract 2 from both sides, does the sign stay the same? Yes, so that is a true statement. 1 minus 2 would be negative 1. That is less than, 0. So that is a true statement. So if you're ever not sure, just plug in some numbers and see if it works. See if it's a true or false statement. Okay, the next one, let's do 4, just because that's the other one that is F2 on your pretest. So the important parts here is the first sign and the last sign. That's pretty much the whole point of the problem. And then what does this mean? C is negative. So algebraically, they're telling me that I'm multiplying both sides by a negative C. Should that yellow sign stay the same? No, they should have flipped it, right? So that is a false statement. Okay, try 2 and 3 real quick on your own. Okay, what do you get for number 2? You add a positive C to both sides. Is this true? Yes, so that is a true statement. And then the next one, you're multiplying both sides by this means positive C. So if you multiply both sides by a positive number, should this stay the same? Yeah, so that is also a true statement. True, true. True, true. Okay, let's do together GI. So if x is less than 3 and x is greater than negative 4, that can be written as negative 4 is less than x is less than 3. So I always suggest putting this on a number line and looking at it. So x is less than 3. So here's 3. X is greater than negative 4. Think about that. Less than 3, greater than negative 4. Where's the shaded area that they're talking about? It's in the middle, right? Less than 3 and greater than negative 4 would be shaded in between those two numbers. So is this a viable way of writing that inequality? Yes, it is. True. And if we wrote it in interval notation, that would be negative 4 to 3, right? And anytime it is a shaded area between two numbers, you can write it as a compound inequality with x in the middle. So that is a true statement, okay? But on G2, there's a big no-no that I see in that, and I instantly know that it's not a true way of writing it. What do you notice about these two numbers? Do what? Yeah, it should be number line order. You should always have the negative on the left and the positive on the right, or the largest number on the right, the smallest number on the left. And if you were to shade this on a number line, so it starts out with less than or equal to negative 2 is to the left, and greater than 5 is to the right. If that's two separate sections, can I combine them into one inequality with x in the middle? No, it needs to be, that's our or statement. Remember that from earlier this year? This or that, it needs to be two separate inequalities. So G2 is a false statement. Okay, and last thing for today is not in your packet, but I have 3 examples. So now we're going to apply all of that we just learned to an absolute value inequality equation. So I'm going to do this one with you, and then I'm going to have you do 2 on your own. So starting off, I'm going to subtract 1 over, so this is just like your homework, so I'm going to isolate the absolute value. So 7 minus 1 is 6. I'll give you a second to write it down. Now, do I want to distribute the 3 through the absolute values? No, that's doing the multiplication. We want to undo the 3 to get it out of the way. So how do I undo 3 times the absolute value? Good, divide, divide. So no different than last night so far. This is all the same. Less than 2. So now that the absolute value is isolated, that means it's by itself with nothing else on the right side, we need to think to ourselves, there's a little difference here. Absolute value is distance. So this is asking me, are there any positive distance numbers less than 2?
Yeah, there's like one.